Hello everyone, welcome to the Data Engineers Club, Sumit this side. Now again, I am coming up with a very interesting interview. So the person who would be taking this interview is Sri Lakshmi and the person who would be attending is Sujoy Das. Now Sri Lakshmi has been working in LTI Mindtree and has overall 8 years of experience with 4.6 years of relevant experience in big data. She has worked on key projects including migration from on-premise to Azure cloud, building pipeline from scratch, optimizing and maintaining them, have predominantly worked in banking domain, trading and utilities domain. Right now talking about Sujay. Sujay is also a Azure data engineer with over 3 years of experience who would be attending the interview and has again worked on migration projects. He is a very hard-working individual. The best part about this interview is both Sri Lakshmi and Sujay Das are Trendy Tech alumni and have learned from me at some point of time in their career. So I am happy about it that both of them are here in one frame conducting and attending the interviews. That's something good to know about. So I am sure you would enjoy this interview. So let's start with the interview.
Hi, Sujoy. How are you?
Hi, ma'am. I'm fine. Thank you.
I'm good. Thank you. So let us start.
Yeah, sure.
Okay. So I would want you to walk me through your latest project, including the tech stack. So,
Okay, sure. So the project which I have been working on is basically the analysis of the supermarket orders. So what happened was that in that project we had orders dataset as well as the customers dataset. The orders dataset contained the information of the various orders placed by customers at different time of the day, whereas the customer dataset contains the details, individual details of each and every customer, their names, their contact details as well, like who made the purchase. These were the two data which we had to handle, and the average size of each data set spanned around 60 to 70 lakh records. Um, the primary objective of the project was to ingest the data from the respective sources, which was HTTPS source, and then ingest it into a primary staging layer, which was the data lake. The data sets were cleaned and joined in the Azure Databricks, and the final output was exported back to the Azure data lake, Azure SQL database, which was being used by the data analysts for insights purposes. So the tech stacks which I used primarily here was Azure Data Lake, Azure Data Factory, and Azure Databricks.
okay, sure. So you have worked on mainly on ingestion and the data transformation part.
Yes.
Okay, okay. So do you know on what cluster config you're working on?
Okay.
Like,
Yeah, got it. So since our data set contained an average of 60 to 70 lakh records, we found that the most suitable and the cost-effective clusters was standard F4S machines, which contained 8 GB RAM and and 4 cores. So we initially used like three worker nodes for our purpose, and that kind of suited our work.
okay, okay, got it. Okay, so do you have, you said you are getting data from a particular API, right?
Yes, from an HTTPS source. Yeah.
Okay, okay. Did you work on any other file formats or different kind of sources apart from this?
Yeah, actually, I have also taken data from Azure SQL as well, and Amazon S3 storage. So
Okay,
these type of and primarily the data sets which I have extracted were in CSV format, but yeah, few of them were in Parquet as well and Delta Lake as well. So,
okay, okay, got it. Okay, so Sujay, what did you learn from this project? Like, was there any upskill, and did you face any difficulty during this particular, doing this pipeline?
okay. So for me, the challenging part was to connect to these sources and derive these data sets and arrange them a landing zone so that the data could be properly maintained there. And the second thing was that I think initially faced a problem like while extracting the data from a source like Amazon S3 storage, since it was on a different cloud platform. But later on, I realized that we had to make use of the access key as well as the secret key, for
Yes.
which we can use it to securely connect to it. The second challenge which I faced was during the processing of these data sets, since they were quite large. The job was initially slowing down, primarily because they were in row-based format like CSV. So what we did was we converted it into a Delta Lake format, since it's much more optimized and it's basically based on Parquet format, which is quite native to Spark. And and for the since we it also involved joining the data sets, and the data sets were quite large, so initially it resorted to shuffle sort join, which again is quite expensive due to the cost that shuffle incurs on our resources. So I resorted it since the data sets were quite low. I mean, since we had to resort to shuffle sort join, I initially bucketed the data sets for an efficient joint mechanism. In that way, I eradicated the need for shuffling. So this is how I optimized, and they face the challenges and optimize them through this manner.
Okay. So do you know about broadcast join?
Yeah, I have an idea of that.
Okay.
So
Okay. So like if I have a particular scenario, okay, there is a table A and table B. Okay, table A is smaller than table B. So which table would you broadcast in this scenario?
in this setup, the table B, which is smaller, will undergo broadcasting. But then again, we have to see whether the size of the dataset is lesser than the auto broadcast threshold parameter, which we have set. So in that case, it would be broadcasted. So for me, that would be table B.
Okay. And yeah, so you said you were doing some kind of data cleaning and transformations, right? Can you just quote one or two transformations, or how would you do data cleaning?
Yeah. So the data cleaning was basically on the customers' details, wherein few of the customers whose age was not present, we had to initially take an average of the data set, average age of the entire data set, and you had to populate the null values of the age with that value.
Yeah.
And the second thing was that if the phone number was not in accordance, like 10-digit accordance of our country, so what we did was we initially replaced extracted the data and separated it out as a bad record, because we wanted to maintain the integrity of the entire data set, like the all details of the customer. So these are the few transformation from the cleaning part. And for transformations, just as I said, the data sets were joined after cleaning, and just that part.
Okay, so you have used pretty much on joining of the data sets, right?
Yes.
Okay. 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 Could you please explain me the Spark architecture?
Spark architecture. Okay. So the Spark architecture primarily follows this master-slave form of architecture, wherein we have a driver node and a lot of worker nodes. So initially, when we submit a job, it goes to the the driver node, and then it basically, once the job is submitted, the resource manager would set up the application master in one of the worker nodes, and the application master is in turn responsible for negotiating the amount of resources that we have specified in the job as well. So and it ensures that the resources which it has acquired is in tight accordance with the principle of data locality. But yeah, then once the resources are obtained, the job is being then sent to these clusters, to these machines through Spark context. And once the task is being executed, it is being monitored by the driver node. And once it is completed, the resources are scaled, and we get the final output.
Okay, got it. So what happens when a particular action is executed? There are transformations and actions, right? So say I execute one action. So what happens in that case with respect to the driver and worker nodes?
Okay. So when we hit an action, what happens is, first of all, it gets resolved into an unresolved logical plan. Like in that phase, only the syntax of the entire code is being checked and passed. After that, it is cross-checked with the catalog, which contains the names of the columns as well and the tables which we have specified. Once it passes through that, it becomes an analyzed logical plan. And after that, the analyzed logical plan is moved through an catalyst optimizer, wherein it generates a final, or I would say an optimized logical plan, which is then subsequently run through a cost model, and a series of physical plans are generated, and the plan which incurs the least amount of cost is finally chosen as the final execution plan for our entire work. So like when the job is like this is the plan or the plan of execution from our submission of the job to the final execution work, like the plan which our Spark initially works on. And when we submit this job, the driver initially I would say it breaks down the tasks into multiple stages, and multiple, and the stages are then further bifurcated into tasks as well.
Okay, so the result, where would you expect to, where would you expect the result in a worker node or in a driver node?
I would expect the result in the driver node, because that is which we use to submit the job.
Yes. Okay. So, do you know about DAG and lineage?
Yes.
Okay. Can you please explain me the difference between these two?
Okay. So DAG is basically the final execution plan, which I said, it is a final execution plan, which on the basis of which our entire the set of actions, a set of tasks is a set of transformation is being done. So DAG initially it shows the sequence of actions which takes place in different stages, as well as the different dependencies between among the stages as well. Whereas the lineage graph shows the lineage of the RDDs, like which RDD came from which RDD after doing certain set of transformation. So this is the difference between tag and lineage graph.
Okay. You mentioned RDD, right? When you were talking about lineage. So, what do you think an RDD is?
Okay. So RDD stands for Resilient Distributed Dataset. It is basically the fundamental data processing unit available in Spark. It is basically the lower level API present there. So what we do in RDD is we basically specify what means how to do it rather than what we need to do. And in this approach, we basically forego the benefit of catalyst optimization, because Spark doesn't get an idea of what we want to do at the final output. So basically in RDD, we specify this set of actions that need to be done in tight accordance sequentially.
Okay. Okay, so yeah, do you know about narrow transformations and wide transformations?
Yes, ma'am. So
Yeah.
these are the two set of transformations that we have in Spark. Narrow transformation are those transformations wherein the number of partitions before and after the transformations remain the same after going through the transformation as well. A few examples of them like filter, map. So if we have 5 partitions before this transformation, once we do it, the number of the partitions remain same, which is like 5 in this case, and there is no shuffling or the exchange of data between the partition. Whereas in case of wide transformations, what happens is we have an exchange of data among the partitions. So a few example of this like being grouped by join. So yeah, and the number of wide transformations define the number of stages that we have in our net.
Okay. Okay. Got it. Okay. So what is it that you do daily in your project? Like basically your activities and like is it only maintenance or the development part? Can you give me a quick walkthrough?
So I can say that it's a bit of a development part because primarily like the most of the time I was engaged in the ingestion of the data set and also in the the processing of the data sets in the using the Databricks as well. So
Okay.
yeah, this was my role.
Okay. Okay. So uh, you're comfortable with Pyspark and SQL both?
Yes, yes, ma'am.
Okay. Okay. So I'll just give you a few scenarios so that just try to answer them. You can take your time, think through, and then answer these questions.
Sure, sure.
Uh, I'll be giving it in the chat window. Okay, I have just given that. Let me make you the host now. You can share your screen and I'll just walk you through the scenario and then you can start answering the question. Okay, so please go ahead.
Okay, okay. So I'm sharing my screen now, ma'am.
Yeah.
So is it visible?
One more. Yes.
Okay, okay. So the question was that we need
If
to,
you,
I believe,
yeah. Can you please
load a
paste
data
the
set.
question over here?
Yeah, 1 second. Is it visible now?
I still see a blank screen. Yeah. Okay, got it. Yeah. So I'll just walk you through this particular scenario, and I would want you to attempt this question. Okay. So there is a Parquet file which is stored in the data lake. I want you to write a Pyspark code to read this file and store it in a data frame. Okay. Remove duplicate records and write back this data frame to Delta Lake.
Okay.
Yeah.
Sure. Okay, fine. So what we can do is, first of all, we'll take a variable df, which wherein we are creating an initial data frame for reading the data from the data lake. So my command would be like asking Spark to read it and then we can specify the file format which is present in the data lake that we want to read it. In our case, this is Parquet format, and it would be, this is basically the path of the file in the data lake. So once it is done, the data would be read into the data frame which I've specified, which is df, and we can do we can use drop duplicates. We have a function or transformation known as drop duplicates. In that, we can specify the columns on the basis of which we want to remove the duplicate records. So say suppose like we have column 1 and column 2, and in that case we need to, like, we have the flexibility of specifying the columns on the basis of which we want to remove the duplicates. So we can use this method as follows, like df, then drop duplicates, and then specify, say, the column name. Say I would say the column name 1 in our case. If we have to use multiple columns, then we have to just separate it using comma, like this way, like call name 1 and call name 2, I believe, like in this manner. So since considering our case, we just need to remove it on the basis of one column, we can use this method. Or what we can do is, or we can use another function which is known as duplicates, that would take care of all the duplicate records on the basis of all the columns at once. Once this is done, we can use this method to write it back. This df.write dot then we have to specify the format. In our case, we are writing it back into the Parquet format. So since it is a native format of Spark, we can either specify it, or we also have the option of not specifying it, because it will automatically consider it to be in Parquet format. So consider that we are specifying it to be Parquet for ease of understanding. Then we have to specify the mode in which we want to write. It is basically overwrite, append, error if exists. So these are the different methods. And so in our case, we'll write basically the overwrite, considering that we are writing it for the first time into the data lake. And then we would specify the path where we are writing it back into the data lake. This is the different path where we want to specify. And once it is done, we would simply invoke save, and this would serve our purpose.
Got it. Okay, I'll just give you one more scenario for SQL. Okay, I just gave the question in the chat window.
I'm sharing my screen once.
Sure. Okay, so there are two tables, table A and table B, and you are seeing a key value combination, like two columns each. Okay, so what I want you to do is give me the output for inner and left join.
Okay.
Yeah.
Sure. So like first of all, like if I have to explain it, then inner join basically searches for the common keys on both the tables, and on the basis of that, if there are common keys, then only it will initiate a join between those two rows. Whereas in left join, what it would do is it would basically consider the keys on the left hand side, and so if it finds a common match with the records on the left hand side key, then it would pad all the records from the right hand table. Else, if it does not find a match, then it would pad the records of the right hand table with nulls. So if we have to specify the final output, then in case of I would say inner join, what it would do is our final output would be, say suppose since we have key 1 and key 2 on both the tables, which can be used for joining purposes. So our final output can be considered it to be like this. For a second, value 2. Considering that we are not specifying or using the key 2 in this case, so in our case, since we have common key as 1, it would show 1 and then A, and in our case AA, and then what it would do is, since 2, okay, so it has 2 as common key, it would give me B and DD in this case, and for the final one it would give me C and BB. So this would be the output of inner join. And in case of left join, considering that table A is on the left hand side, our output would be somewhat this key 1. These are the columns which we are taking it. So like if I have to see then the output of the inner join would be like the similar in case of left join. Bit as like and yeah, the final one would be this, and this one would be null. So this is the final output.
Got it. Okay. Okay. So yeah, I'm good with the interview, Sujoy. So our HR team will get back to you